The third rule in section 3.3 is the power rule, and this says the log of base b of m, this should be to the p power. So let me rewrite it just so it'll be a little bit more clear. It should be log base b of m raised to the p power. Okay, it looks kind of like it's m times p, but that p should actually be your exponent. So the power rule says that this is equal to p times the log base b of m. So if you have your argument raised to a power here, then you can bring it in front, and it's equivalent to that number times your logarithmic expression. Okay, so your directions here say use the properties of logs to expand the logarithmic expression as much as possible, and then always evaluate if you can. So on number 5, you have log base n of x to the 7th. So we could rewrite this as 7 times the log base n of x. Okay, that's all there is to the power rule. We can't expand any further, so that's just your final answer. Okay, if I look at number 6, natural log of the 6th root of x. Okay, we know that anytime we have a radical, that we can convert this to an exponent. It's a rational exponent, which would be the same thing as the natural log of x to the 1/6 power. And then by using the power rule, this would be equivalent to 1/6 times the natural log of x. And so that would be as far as we could expand. If you look at section 4, it actually says expanding logarithms. So you're going to be using the 3 properties that we've talked about in this section, the power rule, the quotient rule, and the product rule, to expand logarithms. Okay, so as I look at number 7, it's log base b of y times z to the 4th. So first I'm going to look at my argument and say, okay, what's going on here? Well, I have multiplication, so that means that I can rewrite this using the product rule as log base b of y plus log base b of z to the 4th. Okay, so the fact that I had multiplication here means that I can rewrite it as a sum. Then I look at each argument, can't go any further with the first one, but the second one has an exponent. So I could reduce this to log base b of y plus 4 times log base b of z. Okay, whatever my exponent is here, by the power rule means I can bring it down to multiply. And then always look at each one to see if you can reduce or evaluate further, which we can't for these, so this would be your final answer. Okay, number 8, log base 5 of 25 over the square root of x minus 1. Okay, first thing I notice is that I have a quotient. So that means I can rewrite this as the difference of 2 logs. So log base 5 of 25 minus log base 5, and that would be of the square root of x minus 1. Okay, then we want to see if we have any powers. We can use the power rule, or if these could be reduced. Well, what's log base 5 of 25? That means 5 to what power would equal 25, and that would be 2. Then we know that if we have a radical, this is the same thing as x minus 1 raised to the 1/2 power, since it's square root. So now we can use the power rule, and it would be 1/2 times log base 5 of x minus 1. And that's as far as we can simplify, so that would be your answer. Okay, number 9, you have the natural log of the square root of x over y. So again, we still have a quotient. Both of my variables are underneath the radical. So what I'm going to do first is rewrite this and say this means the natural log of x over y, all in parentheses, to the 1/2 power. Okay, which we know the 1/2 would apply to the numerator and to the denominator. So now I can rewrite using the quotient rule. Since this is a quotient, I would rewrite it as a difference. So it would be the natural log of x to the 1/2 minus the natural log of y to the 1/2. Then use the power rule, and this would equal 1/2 natural log of x minus 1/2 natural log of y. Okay, those won't reduce any further, so you could stop here. Or you could factor out a 1/2, but I'm thinking on the homework that they want you just to leave it as far expanded out as you can. So I think they want you just to leave it in this form.